Study guide questions. So if we go to question 1, now keep in mind that a lot of these are kind of, if you know how to answer these, there are at least 5 or 6 questions on the actual test that this information will help you out with. A lot of these are not necessarily going to be on the test itself. This is one of them. This has to do with inheritance and scope, like knowing which methods you have access to and which ones you don't, right? So it's asking you of the different non-construct, so everything but the constructors, what can I run with the MasterCard objects? How many methods do I have access to? So if I look at MasterCard, I have only constructors and the accrue method that I wrote, that I'm actually writing from scratch here, even though it doesn't show the implementation. However, I also inherited these 3 from credit card. So I have 3 plus 1, which is
4.
There you go. 4 is the answer. So it is D. That one's pretty straightforward. Did anybody have questions on that one?
Yeah, why does it say 3?
What?
It says 3 is an explanation.
Oh, yeah, it's 4. Sorry. My bad. All right. So there might be some corrections here and there. Which of the following correctly implements the default constructor? Why do both of these work?
Super.
Does the default constructor require us to do this?
No.
Is it a good idea?
Yeah.
Yes. So if this question were reworded and it said, which one is the best one, you would pick that one, right? But technically 2 and 3 work. Why doesn't 1 work? Super. If you're making a constructor and you are choosing to call super in any way in that constructor, you must do that. That must be your first line of code. You can't call super twice, and you have to do it in your first line of code. All right. Correct implementation of the constructor with parameters in the MasterCard class. This one's interesting. By correct implementation, what do you think? What do you think they mean? Is it going to compile and be cool? Current balance equals B. Is that going to be the best thing for us? No, we don't need to set balance. We don't even really need to set the rate. So that's out. Can you set a method equal to a double? That doesn't even make sense. So that's out. Super. Will that actually compile? It will definitely compile. There is a default constructor. Correct implementation. We need a parameter, right? Is this correct? Why? How many parameters does the constructor in MasterCard ask for? Uno. There's not one for 2. Correct answer is D. Question on that one? Any questions on that one? All right. Amex constructor. Why are all of them correct? Super, right? There's both a default and a regular constructor. Do we need to call super in a constructor? Subclass constructors do not require calls to super. However, It's a really good idea to make sure you get value set onto your instance variables. In this case, I'm adding to the balance with charge. Is that an acceptable way to do that? Yeah, it works. You can do it. Questions on that one? So yeah, answer is E. All of them are correct in their own way. Correct implementation of the charge method in Amex. Will all these compile? I think all of them compile, right? Here's the difference. I'm going to explain to you the difference. When you just run charge, that means you're only running the charge method inside of Amex. What's the problem with that?
It's not annex.
It doesn't, well, it is recursive, but the other thing about it is that we would have to write our own implementation for charge in order to do that. But what's wrong with that? Why is that not a good thing to do? It's inefficient. We did it already. So we would, any of our, anything we do here would involve calling super in both cases, right? Because it's already been written. Okay. The only difference with this one is that if there's a cache advance controlled by that Boolean, right? If cache is true, then we want to add the extra charge. But for that, we call super as well, because that's where we have access to the instance variable. Questions? Okay, again, couple reasons. You want to call super because we already did all the implementation. The other reason is that super has access to the instance variable. So that's highly beneficial. Number 6. What's this an example of? Okay, why is it not dynamic binding? Okay, so you're going to get questions like this on the AP exam, and you're going to have to pick one. Here's how I would rationalize this, okay? That redefining the charge method is definitely overriding, right? The problem is that it will result in dynamic binding, but it's not in and of itself dynamic binding. The dynamic binding is something that happens at runtime. So when you run the program, then the dynamic binding happens, but it's not by itself dynamic binding. Make sense? So that's like really tricky. Obviously, I'm not going to do that to you on the quiz, but you should know it. Oh, here's a fun one. Which one of these will cause an error? Why is it E? Okay, accrue only exists in the MasterCard class. Why can't, isn't M a MasterCard object? No, it refers to a MasterCard object, but M is actually a credit card object. So it doesn't have access to accrue.
That is actually worth it.
Unlike Young Chrome, who has access to a very large crew.
Yeah, I think if you say Young Chrome is cool, I think this would be something.
And I'm sure they're all super gangster. All right. Testing polymorphism. How do we test polymorphism? What's polymorphism? I didn't say spell it. What is polymorphism? It's when one method or even a variable has many different forms in different classes and subclasses. Okay? Why isn't make payment? Why isn't that polymorphism? It's in several different classes, right? It's the exact same one in each one, right? Because it's inherited and we didn't override it. What about net balance? Same thing, right? What about accrue? Accrue is unique in the MasterCard object. Why isn't it polymorphism? Because it's only in the MasterCard object, right? It's not, doesn't exist anywhere else. So it's only in single form. So we're left with charge, which has two different forms, right? It exists in one way in credit card and Amex, and it exists in a different way in, or actually credit card and MasterCard, and it exists in a different way in Amex. What's a class cast exception? Okay, here's the skinny on class cast exceptions. They are created whenever you try to cast an object into a class that it is not an instance of. So for instance, if I tried to cast an Amex object into a MasterCard, would that work?
A and E are the same object.
You can't cross-cast, right? If two things are subclasses of the same thing, they're not instances of each other. They're instances of a superclass, right? You can't cast one to the other. Why can't I cast C to a MasterCard? What kind of object is C? Credit card object. Can't downcast to a MasterCard in this case. Sometimes you can downcast, not right here. Same thing with M. Can't crosscast. Everything else. Can't downcast there. So C is correct because A refers to an Amex, and I'm casting it from a credit card into an Amex. That's the only one that will work. There's a more detailed explanation here, but that's the simple version. Hey, Daniel. All right. Transfer method. So we're adding a transfer method to the credit card class. So we create these objects. Is there any reason why I can't do all three of these? Okay, here's how you answer that. The answer is no, there's no reason why I couldn't. Here's why you can do this. Okay, transfer method is part of credit card class now. So it is inherited by all three of these, right? Credit card, MasterCard, and Amex all have a transfer method now. So once we verify that, all we have to do is make sure that we have the appropriate parameters. I need a credit card object and a double. Credit card object, double. Credit card object, double. Credit card object, double. We're all good. Questions? All right. So, one of the many reasons I do not monetize. Exam prep. Okay, so I gave you a little bit of extra exam prep. You are not required to turn in notes on this. This is something that I'm just going to add on there to help you out with. I wanted to go into a little bit more detail on is a versus has a relationships. So if you look at polymorphism, right? So polymorphism is a relationship, or it results from an is a relationship. So if I have a superclass with subclasses, right? my subclasses are instances of the superclass. So for instance, in the car exercises we did, a GMC is a car object. A Toyota is a car object. Composition is a little bit differently, or works a little bit differently. Composition is when we have an object that is composed of other objects. So for instance, if you look at the class that I gave you guys here, I have this engine class, right? Then I make a class car, and I make one of the data members inside the car an engine object. I can also have a transmission object and a suspension object and take data values for those and create new engine, transmission, and suspension objects to be part of this. Now, I can do all this stuff here because I made these I made all these data members public. Okay, but the reality is your real car object you'd probably want it to look something like this if it was a real program. So private data. Private data. I have engine, transmission, suspension objects, and I also have a name for my car. I can take those in as parameters when I create the objects. And now all these object types are part of my car. I have engine, transmission, and suspension. Okay, the other thing, I have the toString here. So down here I can create a main method. Or actually, toString is in all of these. I have car, right? And I can create an engine object. I can create a transmission object and a suspension object. Then I can create a new car, call it Corvette, and I can add my engine, transmission, and suspension to it. And then if I print out Corvette, it runs this toString. Look carefully here, though. I can call these objects now engine dot, right? Transmission dot, and I can run those methods on it. And if I print Corvette, it will get the names from all these things and print them out. So if I run this, it prints all the data on my car. I can also do something like this. I can say Corvette dot get engine, right? Because I have something that returns the engine object, and I can print that out. So I have this get engine that I'm running. And it says it gives me a little bit more information about my engine, right? So that is a composition relationship, right? My car has an engine. My car has a transmission. My car has a suspension, right? My car, it's composition because my car is composed of all these objects. Questions on that one? Make sure you read this one carefully. There's a couple of extra, what do you call it? Exercises in there. Little practice exercises. I don't think any of them are things that you wouldn't have seen before.